Alright, so today what we're going to do is we're going to continue working with solving a system of linear equations. And yesterday we talked about graphing, didn't we? That was section 7.1. And we graphed the two lines after putting them in slope-intercept form, and what were we looking for? To see where the two lines what? Where they crossed or where they intersected. That's correct. Okay? Today what we're going to do is we're going to solve the same set of equations, but this time we're going to use something called substitution. Okay? Now, if I'm sick and I'm not at school, what do I get? I get a substitute, right? So they take out Mrs. Medvick and they put in someone else, right, to take my place. All right. So today what we're going to do is we're going to take something out and we're going to substitute something back in. All right? So first of all, you'll notice that, do you see the first equation says x equals? Do you see that? All right. What I want you to do, and when you do your homework, I want to see this, I want you to circle what x equals. Sometimes it's an x equals, sometimes it's a y equals. So I'm circling x equals. Because it's an x equals, I want to circle the x in the next equation. So the x is Mrs. Medvick, and the negative 2y plus 2 is a substitute. You see that? So now watch what I do. I'm going to write down the 3. I'm going to take out the x. No, it's right underneath there. And I'm going to put negative 2y plus 2 parentheses. So I took out the x, Mrs. Medvick, and I put in my substitute with parentheses. Okay, and because it was x equals, I'm going to put it in for x. If it was y equals, I put it in for y. Okay? And then I'm going to copy down the rest of the equation. Plus y equals 16. Okay? Next thing I'm going to do now is to distribute. So I'm going to use my algebra. So 3 times negative 2 is negative 6y. See how we distributed? Okay, plus 3 times 2 is 6 plus y equals 16. So I distributed. We're using our algebra that we've learned before. Okay, now I'm going to combine like terms. I've got a negative 6y and I got a y, so that is negative 5y plus 6 equals 16. We always want to combine like terms before we add or subtract. Okay, we've talked about that before. All right, now I'm going to subtract what? I'm going to subtract 6. And I get negative 5y equals 10. Now I'm going to divide by negative 5. So y gives me negative 2. Okay? So now I found the y of my ordered pair. Yes, ma'am?
I have a question about for negative 6y plus y equals 16. Why couldn't you do it plus?
Okay, so you're saying why didn't I add the y up above?
Why didn't you just add 6y there with the other y and then it was 7?
Oh, okay, so you'll notice that it's 6y. So what she's asking about is this step right here, right? Okay, so this is a negative 6y, right? So like negative $6, and I'm adding $1. So this is a negative 6y, this is a positive y, and that's why I got a negative 5y. Is that better?
Yeah.
It's a good question. Any other questions on what I did? We're okay? All right, good. I'm glad you said that. So now I found the y of the ordered pair, right? Because I've got two lines, and I'm checking to see where the two intersect, okay? Because I don't like graphing. Graphing is tough. So I found y. Now I need to find the x. I need to find the x of the ordered pair, okay? So it doesn't matter which equation I choose. I'm going to choose the first one, and you're going to see why, because it's kind of cool, okay? So So I'm going to take that equation. I'm going to go x equals negative 2y plus 2. I'm going to take that equation from above, and I'm going to bring it down here. And it doesn't matter which equation you choose. And I'm going to plug in the y. Notice how this works. So x equals negative 2. I'm going to take out the y and put in negative 2 plus 2. X equals 4 plus 2. X equals 6. So now my answer, where these two lines intersect, are 6, negative 2. So if I have both lines, this is where they intersect. So I could either graph them with slope-intercept form and find out where they intersect, or I can use substitution. Okay? I love substitution. It's super easy for me. I like it. Some kids like graphing because they're visual kids. Some kids like substitution. Some kids like elimination, and we'll get that later. Okay? So it's 3 different ways to do the same problem. So right now you can do that with graphing, or you can use substitution. Substitution is a lot less work than graphing. Questions on that? If I checked this to make sure it's right, which equation do I check them in? I need to check it in both. Do they both have to work? If they don't, do I write no solution? No. If that ordered pair does not work in both equations, what happened? You did something wrong. So you got to go back and you got to look. They should check if you did it right. All right? All right, let's move on. All right, this one, the second equation is a y equals. So I'm going to circle what y equals. And what am I going to circle in this equation? The y, because it's y equals. The other one was x equals. So this, I'm going to put in there. You okay? All right, so I'm going to write down 5x minus 4. I'm going to take out the y, which is Mrs. Medvec, and I'm going to put in the sub. Here's the sub. And what do I follow it with? Equals negative 1. Yep. So I'm just going to finish up with that equation. Okay, now I need to do what? I need to distribute. Now some of you might want to do the chop chi. You might want to do that. It might make it a little bit easier for you. All right? So I've got 5x plus negative 4 times 6x is negative 24x plus negative 4 times 5 is negative 20, right? So you got the distributive property again. That's why when kids are like, oh, I don't need to know the distributive property, who cares? Well, it keeps coming back. When you think you're done with it, it's when it comes back. And you're like, oh, crud. All right, now what do I do? Combine like terms. What do I get? 19x plus negative 20 equals negative 1. Yeah, I want to combine like terms first. Okay, now what? Yep. Good. Yep, I'm going to add 20 to both sides. Negative 19x equals 19. Now what? Divide by negative 19. Why negative 19? The number in front of the x, and I'm trying to get x by itself. Right, so what do I get? Negative 1. So x is negative 1, and I'm done, right? I found my negative 1, I'm good, right? Why not? What's wrong? I need to find the y of the ordered pair, because again, it's where these two lines intersect. All right? So I need to find y. I'm going to draw my line across. How do I find it? Where do I go? What do I do? Yep, I'm going to pick an equation from up above. Does it matter which one? It does not. Which one do you want to pick? I'm going to choose the second one because it's actually ready to go because it's y equals. So y equals 6x plus 5. You can choose the other one. It's just going to be a little more work is all. Right? So y equals 6 times -1 plus 5. Okay, now what? Y equals -6 plus 5. Y equals, okay, -1. I'm done, right? Why? I need to do the ordered pair. Absolutely. You're not done until you do it. What's my x? What's my y? Okay, so that is my answer. That is where those two lines intersect. And I'm just drawing it so that you see that's where these two lines intersect. And I can graph them or I can substitute. Okay? Should they check? Yes. If they don't, you did something wrong. Yep, that's right. Okay? Let's look at this one. Now, the first one we did was an x equals. The last one we did was a y equals. Look at this one. I don't have an x equals or y equals. So I've got to do that. Okay? Now, you could do the first equation, but do you see how it's 4x and then minus 2y equals 14? That's not real user-friendly. If you look at the second equation, there's a 2x, but do you see this y is kind of by itself? Okay, so I can do something with this that's really easy. So I'm going to take this y and I'm going to try to get it by itself. So what do? Yep, I'm going to subtract 2x. And I get y equals -2x minus 3. See how easy that was? Okay, if not, you can always put the first one in y equals mx plus b and try to do that. You might get some funky fractions or some decimals. So if you can get it where there's a 1 in front of the variable, like that y, you're better off. Okay? So now it's y equals, I'm going to circle what y equals in this equation. And what do I circle in the other one? The y, because it's y equals. So I'm going to circle the y here, and I'm going to put this in for y. So I'm going to write 4x minus 2 parentheses. What do I put in the parentheses? -2x, yes. Minus 3, very good. Parentheses, and then equals 14. So I try to do it somewhat underneath that equation. All I'm doing is taking this as my big out and putting in a sub. Okay, you're not going to change hours. You're not going to change the people in your class. Everything's the same, but I'm not in the classroom. Okay? Right, and then if you want to, you can do a chop chi. That might be easier for you because you got that negative. Right? I've got 4x plus what? 4x plus 6 equals 14. Okay, now what? What do I get? Excellent. And then? Good. 8x gives me, good. X gives me 1. I'm done. Yay! All done. Y. And you find the y of the ordered pair. Okay? So I need to find the y. Does it matter what equation? No, it really doesn't matter what equation. I don't know. I'm going to do the second one, but I'm going to put it in the original one. I'm not going to put it in the new one. Okay? So 2x plus y equals -3. 2x plus y equals -3. That's right. Yep. And I'm going to take out my x and I'm going to put in 1. Done. Yep.
If you wanted to, couldn't we did like the and put it in that form?
You could put it in that one. The only thing you don't want to do though is if you check these equations, always put them in the original equation. So if you're going to take this and you're going to check it 1, -5, you always use the first equation and then second equation the way it is. Do not take it when I changed it with the blue. And the reason why is if I changed it and I did it wrong, it could still check, like it would work. So you got to put it in the original equations if you're going to check it. And I assume you guys know how to check it because we've done it before. Questions? Okay. Let's see here. One last one. Do I have a y equals or an x equals equation? I don't. Which equation would you like to change? The first one, yeah, it's probably the easiest. Now, with this one, you're going to notice there's a 1 in front of the x and a 1 in front of the y. So you can solve for either. I tend to, if I have this choice, solve for y. Just because we're used to y equals mx plus b so much. And then if I wanted to graph it, I could graph it too. So I'm going to subtract my x. Y equals -x plus 5. Okay, and I'm going to circle what y equals, and what am I going to circle in the next equation? The y. Because they said y equals. So 7x minus 9, parentheses, -x plus 5, parentheses, equals 3. So I'm just taking out the x, making it a little bit, or sorry, the y, making it a little bit bigger and plugging that in. Okay? I would do the chop-chi again. 7x plus 9x plus -45 equals 3. Okay, now what? Combine like terms, I get 16x plus -45 equals 3. Good, add 45. 16x gives me 48. Good. X gives me 3. Am I done? What's wrong? I need to find y. How do I find it? Put it in one of the equations, and I like the first one because it's so easy. Done. Okay. It's actually kind of fun. Once you get it, substitution can be a lot of fun in a math sort of way. I mean, it's not like going to the Mall of America, but it's close. Okay. Questions? Anything I can answer for you? Okay.